Has this ever happened to you? You're minding your own business, and so is your cat. And suddenly you notice, wait a minute, my cat's been up to something, but I can't tell what it is. But it's definitely not eating the way it used to be eating. That's a telltale sign that you have a cat problem and you need to take it to the vet. Normally, pets like to show that they're sick or ill, but the big exception is cats. Cats instinctively hide their illnesses. They don't like displaying that they're feeling sick. And so this is a big problem because how do you, as a responsible pet owner, realize that you need to take your poor cat to the vet? Well, the big telltale sign is that their eating habits change. And so they'll either start eating way too much food per day, they'll start eating erratically, they'll be all over the place, and that's the telltale sign that you need to take your cat to the vet. But, new problem. How do you figure out that they're eating poorly? What are you gonna do? You're gonna stare at them the entire time, the whole day? What are you gonna do, put a camera on them? No. Welcome to TracKat. This project brings together embedded systems, hardware design, software design, and web apps to create a modular system of sensor tags that communicate with a central hub through Bluetooth Low Energy. The hub then tracks eating habits of pet cats and displays it on a custom-made web app. So just on the table in front of me are a couple of the artifacts that we've produced throughout the course of this semester. Starting with the most important components here, we've got the central hub, which is a Raspberry Pi 4. It's a small computer that is running our web application, as well as the software that handles sensing and making use of data that it reads from our tags. The tags are basically right here. So right here you see a bowl, which is a standard sized cat bowl with standard kibble in it. This is sitting on top of a custom designed and 3D printed housing that then inside, internally, houses a custom designed and custom etched tagged PCB, printed circuit board. And so what this tag does is senses the weight of the food and reports it to the central computer. Okay, so we've got our unboxing. Just came in the mail. I ordered this cool new device that should help me keep track of my cat's health. So we've got the plate that houses the load cell, which is the weight sensor, the custom tag with the Bluetooth, and then the load cell sensor. So first things first, we're going to take our standard coin cell battery. This is a CR2032 coin cell. Just going to slide that into the coin cell clip. Let's make sure to turn on the device. Then we're going to take our screw, and then we've got our top section here, nicely custom designed with a skirt to avoid getting any nasty particulates inside the electronics. So that goes flush with that hole. And then we line up the hole with the screw it in place. And we're ready to go.
So here is some of the schematic work and layout that we did for the PCBs. We ultimately chose to manufacture the PCBs in-house because that gave us greater flexibility to prototype and to get quicker turnaround times in our tight schedule. The boards feature a DA14531 BLE module, which has an ARM Cortex-0 Plus processor. It also has a power switch, user button, reset button, coin cell clip, SWD port, and GPIO breakouts. An earlier version had an accelerometer and a load cell ADC built into it, but the current version simply breaks out all GPIOs and uses external chip breakout boards to allow for more flexibility. It runs from one coin cell battery for roughly 53 days according to our power profiler, and this was achieved with aggressive sleep scheduling and rationing of sensing The firmware runs the load cell by firing and handling sysdig interrupts, and stores all values it receives in an array that it then reports to the Raspberry Pi hub when asked. The load cell tag actively filters out invalid values such as the cat nuzzling into the bowl as it's eating, and it also automatically calibrates itself upon startup with a baseline value. It also automatically detects food refills, so the user doesn't have to tell the system that they refilled the food.
Another thing came in.
Alright, so the hub is running from a Raspberry Pi 4, that's the central computer to which the Bluetooth tags communicate. The hub connects via Bluetooth, low energy, to the food bowl and water bowl tags, and reads in little endian byte arrays. For each of the bowls, it reads in the weight, the timestamp, the microchip arrays, and they're all converted into integer values in grams, seconds, and microchip numbers. The hub then separates the weights and timestamp values based on each unique microchip value. Then, using the raw weight values, it calculates the food and water as volume, as well as how much was consumed, all the while catching errors and edge cases. These are then stored into the user's cat's JSON file if the microchip matches, meaning a specific cat has come to the bowl. After this process has completed updating all the user's cat's information, data analysis is performed. If a statistical anomaly, meaning a value outside of 2 standard deviations from the previous data, happens where either the cat has consumed too much in a sitting or has taken too long to eat or drink, the user is notified by having an email sent to the email they entered during registration. Alright, so here's our web app. So on the registration page, the user can create an account with their name, their username, and a password. They can also input contact information, so an email and phone number. And finally, they can select how many cats they want to track, as well as if they want to track food, water, or both. The system will dynamically adjust to their answers. Lastly, they'll enter the actual hardware Bluetooth addresses for the bowls that they're tracking. On to the next page. Here the user registers their specific cats with their name, their age, their weight, their unique microchip number, as well as the weight of food per volume. Once that's done, they're brought to their home screen with their profile, where they can select the graphs for the different cats that they're tracking, as well as refreshing the graphs with a button. The refresh button connects with the Bluetooth hardware and fetches the latest values and updates the graphs. Each of the cats the user registered has its own customized page, which tracks their food and water intake depending on what the user chose to track at the time of registration. If a value crosses the danger level, the user is sent an email warning them that their cat may be overeating or overdrinking.
Okay, so we're going to do a quick demo here of the food bowl in action.
So to demonstrate the functionality of our design, we're demoing with tracking some food. So here I am basically scooping food out of the weight tag bowl. We then refresh the page through the web app. So let's see where that put us. So here we see my small scoop, big scoop, and then small scoop again. So the last value looks like 3.11, so let's remember that value. So then I'm going to go ahead and scoop again, small scoop, let's do a big scoop, and then a little tiny scoop there. Alright, and let's refresh the page again. Remember, it was 3.11 was the last value. So we go to our cat's graph, and there it is. 3.11, then a small scoop of 4, then my big scoop, and then a smaller scoop. Perfect. Next up, we want to show off the error notification from the web app. So we're going to enter a preset profile that has a value that surpassed the threshold. So when we refresh the graph, it'll run the calculation again. Notice that the value has in fact crossed the danger level, and will then automatically send a warning email to the registered user. And there it is, 0 minutes ago, right there on the spot, we get an email saying that we've noticed a problem with your cat. Great.